Public blockchains are powerful because anyone can verify what happened. But that same openness creates a privacy problem. Wallets, payments, patterns, and relationships can become visible. Before we discuss zero knowledge, let's look at what public activity can reveal. We've seen why Ethereum scales through layer 2s and how ZK-rollups use proofs to make execution efficient while inheriting Ethereum's security. Now the focus shifts to privacy. Because verification depends on public data and transparent settlement, observers can study transactions, activity patterns, identities, and holdings. Open data is what makes blockchain verification possible. Anyone can inspect transactions, balances, and contract activity, which reduces the need to trust a central operator. The trade-off is privacy. Financial behavior, business relationships, and user patterns can be monitored and analyzed over time. Transparency is not only a security feature, it is also why privacy has to be designed deliberately. A public blockchain is not just a payment rail. It is a shared record that preserves history. Every address leaves traces: who it interacted with, how much value moved, what fees were paid, and when. Balances and token holdings can often be queried directly. Contract calls add even more context, revealing swaps, loans, NFT activity, votes, and claims. Data that seems harmless today may be linked and analyzed years later. Each transaction is more than a receipt. The sender, recipient, amount, timing, contract call, gas price, and event logs all become clues. One transfer might suggest a payment relationship. A DeFi transaction can expose strategy, leverage, collateral, or liquidation risk. NFT activity can signal identity, taste, and community ties. Even gas choices may reveal urgency or automation. Privacy risk grows as these clues are connected across many transactions. A blockchain address hides your legal name, but it does not make you anonymous. Think of it as a consistent nickname. If that nickname touches a centralized exchange, a social profile, an ENS name, an NFT community, or a donation page, it can become linked to you. And once one wallet is identified, transaction patterns may reveal related wallets. Privacy depends on reducing linkability, not just using a new address. Identity linkage rarely happens all at once. Imagine Alex withdraws funds from an exchange, registers an ENS name, mints an NFT, joins a DAO, and uses the same wallet in DeFi. Each action may seem harmless, but each adds another clue. An observer can connect the exchange entry point, public name, social posts, and app activity into one profile. The risk is wallet reuse turning normal participation into a behavioral fingerprint. Privacy is not only about names, it is also about habits. If the same wallet receives funds every Friday, swaps soon after, and uses the same apps, that rhythm becomes a signal. Even with new addresses, similar amounts, timing, and sequences can connect activity. Analysts can cluster those traces into a behavioral fingerprint. This applies to bots and institutions, but also to ordinary users following predictable routines. On-chain analytics begins with raw transactions, addresses, contracts, and token movements. Indexers organize that data so it can be searched quickly. Labeling adds meaning. An address may be an exchange, a bridge, a DAO, a whale, or a known exploiter. From there, dashboards can reveal flows of users, liquidity, and protocol adoption. This intelligence is useful for compliance and security, but it also creates privacy risk by analyzing behavior at scale. Clustering treats several addresses as a possible group when behavior suggests common control. A shared funding source, repeated transfers, or the same exchange, bridge, or contract interactions can all strengthen that signal. But the key word is possible. These links are heuristics, not proof. One service, bot, or user may be involved, but unrelated users can also share infrastructure. Good analysts use clustering to guide investigation while clearly marking uncertainty. Transaction graph analysis asks a broader question. How did value move through the network? By following edges across multiple hops, analysts can connect sources, intermediate wallets, DEX trades, bridges, and destinations. Large or frequent flows reveal hubs, while centrality highlights influential addresses. Even when routing becomes complex or mixers are involved, interaction patterns can still expose timing, dependencies, and likely fund paths. Maybe begins before a transaction is finalized. When a swap, liquidation, or other action enters a public mempool, its intent can be visible. Searchers and bots scan that flow for profit opportunities, such as arbitrage, front-running, or sandwich attacks. If they act first or insert transactions around the user, the final block can change the outcome. That is why strategy privacy matters for traders, market makers, institutions, and protocol treasuries. Privacy risk is not one size fits all. For individuals, exposed balances and transaction histories can reveal income, habits, donations, or sensitive affiliations. For institutions, treasury movements and trading activity can leak strategy before decisions are complete. For protocols, public activity can reveal liquidity dependence, user concentration, and governance patterns. Transparency creates observers, and those observers may be researchers, competitors, or attackers using timing and context to turn visible data into leverage. Public blockchains create trust by letting anyone verify that the rules were followed. Yet the same openness can expose balances, strategies, customers, and business relationships. The goal is not total transparency, and it is not total secrecy. Responsible privacy design reveals enough for auditability, security, and compliance, while hiding details that should not be public. The strongest systems make verification possible without forcing everyone to disclose everything. Public blockchains make verification easy, but they also expose lasting patterns: transactions, balances, timing, identities, and relationships. Analytics can turn that visibility into intelligence. Now that we understand the privacy problem, we can evaluate ZK privacy, examine rollups carefully, and design systems that protect users responsibly.